So first of all, I just want to say I'm really honored to be here in India for the launch of the 23116. For me, it's really a watershed event because here we're launching a truly state-of-the-art machine on the one hand, and then on the other hand, we're looking at introducing digital technology. And really this powerful combination of physical plus digital is a major emphasis for our company. In fact, if you just go online and download the 2015 annual report from GE, you don't even have to go past the first page. We're talking about building a digital industrial company, and I emphasize the word digital. So we're really excited about this opportunity. You know, when we think about, you know, I think that the way we need to look at this is we got to look at this from the perspective of our customers, and we want to connect with our customers. We want our customers to really try to think about what this is going to mean for them. And I think the first thing we're going to do here is roll a video.
GE's digital wind farm is moving the wind industry decades into the future by combining the smartest, most advanced hardware with the power and flexibility of the industrial internet. It begins with GE's revolutionary turbine platform, individually configurable to optimize performance across the farm. Then, each software-defined machine is connected to the digital infrastructure powered by Predix. Get connected, get insights, get optimized in real time, all from the palm of your hand. With the digital wind farm, tomorrow is today.
So this is really a big bet for the company, and I think something that's really interesting to consider is over the past 20 years, the software industry has learned something profound. And what they've learned is that really you need to consider software from the perspective of the users. I think it's one thing to go off and build a software solution. It's a totally different thing to think about how people interact with the technology. I just think about, you know, your interaction with an operating system from the DOS days to now how you interact with your smart tablets. And I think my point here is that this is actually a methodology that we brought to bear on our development of the digital wind farm. We're really thinking about the key users in our customer base. So I would start fundamentally with the plant managers, right? These are the folks who are really focused on maintaining uptime on the machines. They really care about just two things. They care about availability and they care about reliability. Then you move on to consider the asset managers, the fleet managers. You know, they understand that this is a long-term investment, right? A 25 to 30-year investment. And they're really looking for a financial return on that investment, and a financial return that should get better year over year. Now, for these folks, there's really two other levers, right? For an installed asset base, you really want to create more power on the one hand, and you want to reduce your operating costs. So you want to be able to look at every financial line item in your business plan and beat it year over year. And finally, moving to the far right, there are the folks who are running the business. We all know we're in a global market that's growing, extremely exciting. But the challenge here now is to find profitable projects and to invest in those projects in a way that doesn't put the company at risk. And so when we think about digital technology from the perspective of these users, that's really the framework. I just wanted to give you a little bit of insight in how we're thinking about developing this digital solution set. So with that, this is how we think about our digital offering, and this truly is the digital wind farm. We've got, you can see that our product layers are really aligned with these personas I spoke about. And I'll take this chart from the top. We all know, and we've heard it multiple times today, that there's a real challenge with renewable energy in that it's, the fuel source is intermittent. And yet it's still got to play nice with grids in every global location. That really puts a premium on the ability to bring technical solutions that help mitigate that problem. We truly believe that energy forecasting is one of those, and it's a really neat play from the perspective of, in some sense, it's almost a pure digital technology. We're investing heavily in this space to bring forecasting at multiple time scales from real time all the way to many days ahead. And actually, there are some markets in the world for which we think we're going to extend this out into a bidding platform. One level down in operations optimization. So now this gets over to the persona of our asset manager who's interested in creating more power out of our assets. We already have a platform we call Power Up. And many of you might be familiar with that. The idea here is to continue to invest in that platform and extend it. And actually, we're very excited that so traditionally the Power Up platform has been all about upgrading the turbines themselves. You now start to think about the possibility of having collective intelligence of all the turbines, like we saw in the little demo this morning, or earlier today. And I think wake management is a particular example of that, where aggregated information flow in the wind farm creates a better outcome, in this case, more power output. And then the final application I'm going to talk about, which I think is really a quintessential big data play, is asset performance management. So there are these models out there for big data, right? And if you think about data volume, so imagine aggregating all of the SCADA data from the wind farm into one location. You're talking about thousands of tags at one tag per second. You think about the velocity of data, so the technical folks in the room would realize that the condition monitoring systems that are monitoring vibrations on the turbine, that's very, very high frequency data. And then you think about data variety, so the ability to take in oil samples, the ability to take in diagnostic information from the farm, take in logs from the service technicians, and ultimately even electrical signatures. You bring all of that together into a set of diagnostic and prognostic algorithms. So that sounds really fancy, but to me, I come back to the thing I said earlier. You really need to connect with people. And so in this asset performance management platform, we really need to take all of these, all the great findings from these algorithms, put it into a case management system, let people see the value of the diagnoses, and really drive it to the bottom line so people can see the value in investing in this kind of technology. And that's what asset performance management is going to do. So the final thing I would just mention here is the platform that underlies all of this. We've heard about the Predix platform. All of these applications will be built on the Predix platform. We're very excited about that. And I won't let it go unsaid that we're going to continue to invest very heavily in our underlying turbine controls and plant level controls, as Paul spoke about.
So we heard two major things this evening. One of them was about reducing the cost of energy in general, and second was about forecasting and how it helps integrate more and more wind power into the grid. And we want to share two case studies, two applications that we've actually demonstrated on both of these requirements over here in India. The first one is something called as wind power up services, where what we essentially do is make a couple of changes in the software, in the controls, in the way turbines are operated throughout their life, as well as a few changes in the hardware. And this is a mix of different technologies that we use to be able to increase the energy output, the annual energy production of the wind farm as a whole by up to 5%. So it's a mix of different technologies, and we use a lot of big data and analytical capabilities, as well as the Predix platform that Dave mentioned about, to be able to increase this energy production. In fact, we did this very recently at Gurukapa's wind farm over here in Karnataka. This was their 1.577 machines, which were around 3 years back commissioned. And in these machines, we simply changed the software and control parameters while maintaining the design envelopes that we had on mechanical loads, on electrical loads, on civil loads, and ensured that they still got 4.8% increase in annual energy production. Now imagine when Gurukapa made their financial pro forma 3 years back, this extra AEP was not really figured in that equation. Now this is, and with all the pun that's intended, this is actually a windfall gain for them. But the critical thing over here is we increased energy generation while making sure that we are not crossing any of the engineering load limits that we've set on the turbine. Now, because we collect data from so many turbines globally, in fact 19,000 turbines globally right now, we knew what the levels where we could extend as much as possible. You know, it's like cricket today. We all want Kohli to score 12 runs and over, but we still want him to last the full 20 overs, right? Everyone wants more and more output. You also want to conserve the turbine life as you want to do it. And this is something that we've demonstrated in India, and of course thousands of turbines globally as well. So that's about Power Up. The second application we want to talk about is wind power forecasting. It's been a very popular topic in the industry for the past 2 or 3 years now. This regulation on forecasting itself has evolved a lot over the past 2 years. from forecasting on a day-ahead basis with 8 updates per day and plus minus 30% error margin to today where it is a plus minus 15% error margin and 16 updates today. It's evolved a lot over the past 2 years. What we've realized with forecasting in India is a couple of issues, and these stem because of the kind of technologies that are used on forecasting. Usually the forecasting, it's not used. So most forecasting technologies are a mix of two technologies, numerical weather prediction as well as statistical technologies. And what we've seen particularly in India is because of the granularity of weather data that we have over here, the forecasting accuracy gets affected. The second major issue is most of our wind farms are located in remote areas, which means that sometimes there is loss of internet connectivity, and forecasting models that operate over the cloud or remotely do not get the operational data, the statistical data that comes in from the site SCADA back to their servers. Now that causes an error in forecasting. The third problem is because of the way our forecasting metrics itself are designed in India, the way we have to forecast for a 15-minute interval, adopt a particular number of updates per day. If you're using global models which are not customized to the Indian metric that you're going to solve for, you are going to see errors in forecasting over there. And the last one is, of course, the lack of turbine data itself. Our solution, which we built on the Predix platform, tries to address most of these problems. It's developed in India. It's developed for the Indian metric that we are trying to solve for. So all our algorithms, all our analytics are very, very unique to the Indian requirement. The second thing is, this is the typical Indian innovation that we've done in terms of the architecture itself. We do have forecasting that operates from a cloud, from a remote location. But we've also got forecasting that is being done at the site. So even if there are internet connectivity issues, our site-based forecasting still works in that case. The third thing is the forecasting regulations clearly state that these are going to evolve over time. Bands could get tightened. You might have a different error metric later on. So our platform based on Predix actually incorporates that flexibility for the future. And of course, the user experience that comes with Predix is phenomenal. But one major thing that we've also done is we are so confident of our forecasting accuracy, we today offer a commercial model which is based on pay for performance, which means we are very accountable for forecasting. We charge a fee based only on forecasts that are within the plus minus 15% band. Any forecasts that deviate outside of that band, we actually pay a non-performance fee in those cases. In fact, we demonstrated forecasting for over a year with one of our customers called Panama Wind at their site in Maharashtra. And over this 1 year of period, including the high and low wind seasons, we had 94% of generation falling within the plus minus 15% band that we have to adhere to. With that, may I request actually the CEO of Panama Wind, Mr. Dinesh Chagdale, to come up and share his experience on our forecasting. Incidentally, he's also the first customer to have signed up on this platform. So please.
Good evening. Thanks, Milesh, for the nice introduction. I'm Dinesh Jagdale, and we are an IPP under the name Panama Wind Energy, having portfolio at present in Maharashtra and trying to do something in other states as well. Yes, I think the relationship that we have with GE goes back to around 4 to 5 years back when we first started our project in Maharashtra, and we installed the first of its kind GE 1.6 82.5 meter rotor machine. We do understand the regulatory scenario has been working around the scheduling and forecasting over the last 5 years. There has been ups and downs. The industry has been really representing its own problems, and as ma'am suggested, yes, the regulator also has been trying to understand the needs of the utility and trying to bridge the gap between the expectations of the utility and what operators and the manufacturers can do in terms of scheduling and forecasting. But we as a responsible entity from a generating perspective always wanted to ensure that our wind farms are capable in addressing the needs of the regulator, addressing the needs of the customer where I'm going to sell the energy. And that was scheduling and forecasting. So over the last 2 to 3 years, we started our experiment. We initially had some consultants from Europe to do this, but somehow we found that the accuracy that was envisaged by the regulator at that point of time had a different sort of formulas, and we were not able to meet those because of the intermittent nature of the wind. So we could not do really much on that level, and then when we had the relationship built with the GE, when GE came up to us about these predict solutions, about the forecasting, we engaged into a dialogue, and over the last 2 years, I'm proud to say that we have come across and partnered with the right technology, wherein 94%, ladies and gentlemen, it's a huge accuracy that I can say, 94% of the energy that was generated by my wind farm at Satara site in a very remote area, where today connectivity itself has its own issues. It took at least 2 years for BSNL for me to provide a 2 Mbps line in order to forecast. So in spite of such huge issues that came across our sites because of the nature of the digitization that we are all talking about, the cloud, and the amount of forecasting that can happen at the site level, as well as from the anywhere, from the cloud level itself, we are able to meet, and I'm proud to say that we are prepared for the challenges that the regulator is facing today, and we definitely will be able to comply with those standards as soon as the drafts becomes final. Milesh, you talked about pay for performance. That absolutely was our requirement, because we absolutely, this is an additional type of penalty that we as an operator are going to, we as an IPP developer are going to face, because this is not taken in the tariff when the tariff is decided. The tariff is decided somewhere 2-3 years ago, and when a project is envisaged, a new regulation comes, and we will have to bear that cost. So a pay-for-performance model also becomes more helpful in reducing the amount of penalty that we would be really facing because of the intermittent nature of the wind itself. So thanks to GE for coming that. And also one more thing is that whatever losses are there, they will also be trying to share some of the losses. For example, 6% of the energy that was not in that band of plus minus 15%, there also some sharing can happen. Thanks for that proposal as well. And thanks for giving the opportunity to express me once again for the award that you got, the recognition that GE got in the Indian Wind Energy Forum. I again congratulate you, wish you all the best, and keep bringing in new solutions for us, not only to upgrade our power, but also to meet the regulatory needs of this country. Thank you, ladies and gentlemen.
Thank you so much, sir. You've been a great champion of digital technologies in the industry. And it's in our interest, sir, trust me, to increase that 94% generation to higher and higher levels. We do not want to pay those non-performance fees to the extent possible. But ladies and gentlemen, we also have all of these digital wind farm applications being demonstrated over here at the experience zone. And towards the end of this, conference, we would urge you to please have a look at that as well. With that, may I pass it out to Mahesh for the final proceedings, please. Thank you.